So good afternoon, everyone. We'll be starting the meeting in around 5 minutes to give enough time for other people to join the session. So I guess we can start. So first of all, good afternoon, everyone. It's my great pleasure to welcome you to this Waterline virtual forum that is happening for the first time here in Malta. And this national event forms part of the Horizon Europe funded Waterline project. And today marks the beginning of what we hope will be a meaningful and energizing two event on two separate days, discussions on the future of water innovation here in Malta. A future that is grounded in digital transformation, interdisciplinary collaboration, and forward-thinking policy. This forum brings together experts and representatives from academia, industry, government, and civil society, what we often call the quadruple helix, to explore a shared question: how can we bridge the gap between research practice and policy to accelerate digital solutions in the water sector. At the heart of WATERLINE is a commitment to strengthening research and innovation capacity in higher education institutions. But more than that, it's about anchoring that capacity in real-world challenges and delivering value to the wider ecosystem. That means fostering knowledge exchange, developing practical technologies, and aligning these innovations with policies and public needs. Over the course of these sessions, we will aim to achieve three objectives. Firstly, to build stronger bridges between Maltese stakeholders, particularly in research, industry, and policymaking, especially in the context of the topics we're discussing, which is digital water and smart water systems. Secondly, to create a space where, as researchers, we can gain insights into the industry needs and the challenges faced by NGOs as being represented end users and the pathways towards commercialization products that can be a result of this innovation. And thirdly, to explore how current research can inform and shape national water policies. Through collaboration, both from a technological development and also from enhancing the already well-established stakeholder collaboration that there is in the Maltese water industry sector. So today, the main focus of today's session will be focusing on industry needs and the commercialization opportunities that are here. And we will hear from thought leaders and practitioners who are working at the forefront of the digital water space in Malta, but even beyond in Europe, from looking at AI-powered optimization that is happening at Water Services Corporation to European initiatives such as Watershare, ideation, the ideation project, and digital twinning. In fact, we are honored to be joined by a distinguished group of speakers and panelists, starting off by Dr. Lydia, the Director of Watershare, will be delivering our keynote and providing a European perspective on digital water transition within the water sectors. We'll then also see a live demo from a colleague of ours at MCAST, Mr. Daren Scerri, who will be showcasing an immersive digital water tool that was developed right here at MCAST. In our panel discussion, which is an interactive panel, we'll bring back Lydia back to this discussion, along with Dr. Michael Schembri from the Energy and Water Agency, Dr. Alex Rizzo from MCAS, Daren, and from the Water Service Corporation, Owen Attard and Claire Gallia, who will offer some industry insights into real-world development and deployment of digital water technology. Later, we will hear from Dr. Eloisa Vargiu, who will present the ideation project's roadmap for a digital twin for inland waters, a forward-looking concept at the intersection of technology, policy, and water resource management. Each of the speakers will bring a valuable and unique perspective from both a EU-level policy to on-the-ground implementations. In fact, this forum is designed not just for a presentation, but for a real constructive dialogue. And I would like to take this opportunity to encourage you, our participants, to engage actively during the interactive sessions by asking questions, offering your insights, sharing your reflections, because this is an opportunity to be part of a conversation, whether you represent the policy side of things, whether it's academia, industry, or community. For us, your voice matters. The future of Malta's water sector will be shaped not only by innovation, but by inclusion, by a shared ownership and collective ambition. Before we begin, I'd like to sincerely thank all of our speakers, everyone who contributed to organizing this event, and of course, to you who have for being here and joining us today. In fact, I think we can now commence, and I would like to look forward and augure you a very productive, inspiring session. Hope that will connect ideas, and hopefully it will be a platform so that we develop and further from this. Thank you. I would like to now ask Dr. Lydia to give her keynote speak, and I'll pass the floor to her.
Thank you. Good afternoon, everyone. I'm going to share my screen. Let me find first what I need to share. Right. So I'm sharing my screen. I'm putting the presentation mode. Right. Is it okay? Can you see it?
Yes.
Right. So my name is Lydia Vamvakeridou-Lyroudia, and I have a double affiliation. I'm at the Center for Water Systems at the University of Exeter, and that's how I participated in WATERLINE, but also I'm at KWR Water Research, a research organization in the Netherlands, representing all the water utilities of the Netherlands, plus the biggest in Belgium, in Flanders. And as a Watershare, in Watershare, one of my roles is to be the director of Watershare, which is an international knowledge exchange network. I have also a big involvement with digital water through the European Union, through the Commission, by coordinating the cluster called ICT for Water, which is a cluster of 85, maybe more now, projects that have to do with digital water. But we're going to talk about this later. So my presentation today is to present you with a digital transition for the water sector, the challenges and opportunities it offers. When we're talking about digital water, we're talking about two things: the value of data and the value of water. And digital water combines the value of water with the value of data and the knowledge management, and is essential for water saving, water efficiency to face water scarcity and climate change challenges. It leads to many things. It leads to smart water management, smart homes and smart cities. I should also say intelligent water management, and needs to be implemented various tools. The tools needed are digitalization and integration. By that meaning combining data, combining sources and signals from multiple data sources. It needs visualization and visualization tools like digital twins, augmented reality, virtual reality, which virtual reality is something that WATERLINE also has contributed. It leads to digital business models and access to data by customers, and of course to related products and services which form the business model of this. Now, what does it cover? In one word, it covers the whole inland water cycle, the digital transition for the water sector. And it covers everything. It covers drinking water and water supply, sewers, wastewater, pollution, treatment plants for drinking and for wastewater, flooding, river management, landslides, groundwater management, irrigation and water for agriculture. It covers also circular water and water reuse and alternative water resources, for instance, desalination and rainwater harvesting. It links also, it should link with ocean water, and you're going to hear more about this for Eloisa Vargiu in the end through the project ideation. And this is necessary for estimating the impact from sea level rise, wave modeling, offshore and tidal energy, which is essential for the protection and the study and the mitigation of coastal regions and adaptation to climate change and erosion. It needs also to link with marine water, for instance, for water quality for fisheries. And all this needs to happen in a holistic way. Does it happen today? The answer is no. At the moment, the digital water for the inland water cycle operates in a very different way, a separate way for the digital water for ocean water. It's not linked. Recently, the Commission has started thinking about linking them, and that's why you're going to hear about this ideation project in the end, which paves the way for the linking the inland and the ocean water digital twins. But it has not happened yet. Digital water poses challenges for the water sector and the water utility. And this is more intensive because the water sector is generally conservative and fragmented. When we're talking fragmentation, there are 68,400 water utilities in Europe alone. Because in some cases, in some countries, there are large water utilities, but also there are countless villages and small communities that have their own water utility and their own water services, and that means fragmentation. And also the water sector is very conservative, much more conservative than, for instance, the energy sector. And the other problem is marine and maritime water are faced separately from the inland water, which I spoke about already, and this is a major issue and a challenge. And also information science, data science, and digital technology are relatively new and recent additions to water management, which means, artificial intelligence, its potential, has not sufficiently been explored or implemented by the water utilities and the end users, but everybody is rapidly increasing to a new digital reality to which they need to adapt, and that needs to smart, intelligent water system management. So we can say that today the water sector is in digital transition from a previous condition of operation to a new one that is more closely linked to the digital world. And this digital transition is essential, but also very difficult for the water sector because it needs a lot of things. It leads towards the Internet of Things era, which with multiple data sources, sensors, images, image processing, and various types, even social media processing. Across sectors, we cannot operate separately from the energy or the weather. We need the weather and energy. We need also other sectors, like, for instance, transportation, to make decisions in digital twins and to make a transition towards a smart city. It leads to real-time operational management, which is new for many utilities. And it needs, of course, interconnected systems, and that means the end of isolation. That's important because the water sector and the water utilities have been used in operating isolated. They don't exchange data traditionally with anyone, and this needs to end. This is essential for the digital world to end, and that poses opportunities, but also new risks, like cybersecurity risks, which need also to be faced. It needs to have, for this digital transition, we need to have cloud services, data exchange, data fusion, and of course, all this is necessary for the digital twins for operational management. And the requirements are integration of everything, interoperability, very important. You cannot exchange data unless you have the protocols and the standard way to exchange them. And for this is essential that the Commission has done many efforts on this, one of them being the FIWARE platform, which is a platform for data exchange for the smart digital future, and of course standardization. Standardization in data architectures, and data exchange. This, we are moving towards there. We're not there yet for the water. And I spoke already about the ICT for Water, which is a cluster of 85 EU-funded projects on digital water and the transition. It works towards the transition for the water sector. It has produced many things, including the Digital Single Market for Water Services Action Plan. This was first produced in 2018, published by the Commission, and shows the needs and the gaps in specific actions for this digital transition. It was revised in 2023 and updated with the new needs and what is the current situation, because many things have changed. It's a rapid transition in the last 5 or 6 years. And we are planning to provide new updates in a couple of years as needed. So, what is the landscape, the Commission for Digital Water today? First, I'm going to present what was the situation 10 years ago. 10 years ago, we had gaps on ICT, of course, and digital water, and these were focused more on decision support systems and strategic or operation optimal management of water systems, mostly focusing on design. There were smart water applications development real times, but the strength was on computational strength, whether the computer or the program is strong or fast enough, on sensors. There were the first attempts on standardization and interoperability, still not developed enough for the water sector. The Firewall for Water started to operate, I think, in 2016, so it was not even there, the Firewall platform. And the cross-sector initiatives were not prominent. The water sector was still isolated. The emphasis 10 years ago, the buzzwords were smart, optimal, and sustainability. What happens today and for the future? We have broader aspects related to ICT for water, Green Deal policies, related also to ICT for cross-sector synergies with the energy sector. Climate change issues are now prominent, which means that we need also links with the weather forecasts. We need links with transportation in case we have flooding and we need to see what's happening or what measures need to be taken and so on and so forth. New themes and topics have been added in the interest for the digital transition. Circular economy, resilience to climate change, which is different from sustainability. And I'm going to speak about this also in the end. Resilience is not the same. We are hearing in the last year a lot about water resilience, and this is not the same as sustainability. We can say that sustainability is a subset of resilience, but not all of it. New activities through citizen science for data acquisition and has been promoted, and all these are linked to the water sector. Europe has made many moves for data spaces, common data spaces, thematic data spaces that are being promoted and created, and now recently also moving towards the water data spaces, not there yet. We are involved in another project called Waterverse. Eloisa was going to talk perhaps also about this because we are together in this. And we are moving towards that. We're not there yet. There are data spaces for other topics like agriculture or health or energy, but not yet for the water sector. It's going to be created. And the data spaces pose different problems, ethics, legal issues, structure, and all these need to be faced. We are moving towards smart cities and digital twins, which means IoT, Internet of Things ecosystem, artificial intelligence methodologies that also lead to artificial intelligence credibility and robustness issues that become mainstream and prevalent. For instance, explainable AI, reinforcement learning being incorporated into the design, but also the recent LLMs models with ChatGPT, which their usefulness, their real usefulness for the water sector has not been yet fully exploited. It leads to supercomputers and new IT architectures emerging for cloud, edge, quantum model computing, and the emphasis now has moved for smart to intelligent, holistic across sectors, and also with co-creation with the citizens and resilience. Co-creation is also important. You cannot have a bunch of experts going to a utility or a community and saying, this is what you need to implement. There will be reactions. The public, the stakeholders, the citizens need to be aware of the needs, need to participate in the design of their own solutions that have to do with the environment, but also with the digital water. So, The water sector today faces challenges. The 5 main digital challenges at EU level are: the first one has to do with the European Data Act. The European Data Act, which you can find online, is about making data more accessible and usable, encouraging data-driven innovation and increasing data availability that leads to European data spaces. Ultimately, Europe wants a single European data space that improves data interoperability and data exchange, and also provides a genuine single market for data open to data from across the world. And this challenge needs to be met. The second challenge has to do with the Artificial Intelligence Act. The European Commission is committed to enabling scientific breakthrough, to preserving the EU technological leadership, and ensuring that new technologies are at the service of all Europeans, improving their lives while respecting their rights. You have heard perhaps about the GDPR the requirements now, about personal data, but also about spreading false news and other things that are happening with LLMs. And all this needs to be faced with the Artificial Intelligence Act, and water utilities cannot evade this. They need to comply, and they need to move and comply to the Artificial Intelligence Act. The Green Deal, including net zero goals, stating that the full benefits of the digital transformation need to support the ecological transition. Actually, with the Green Deal, the digital and the green transition and digital transition become parallel. We cannot move to one without the other, and the utilities need to face this. We have a new drinking water directive since 2020. And there is a major shift in this drinking water directive. In the old days, in the previous directive, that was since 1999, I think, for 20 years, we were facing thresholds. I mean, if there was a substance that was in the water, in the drinking water, above or below the threshold, that was the only thing that was compared. If it was below the threshold, it was okay. The new drinking water directive poses a revolution, introduces the risk-based approach, which means it doesn't matter if the threshold it's below the threshold. If the risk is above something, it needs to be faced. And every decision, everything that is happening for drinking water safety is risk-based. Risk also means a lot more digital transition, a lot more digital applications, and this needs to be faced. And last but not least is the shift in the last year, which also has been published in February 2025 officially, is the water resilience for the water. It's a major move from the classic sustainability approach to resilience. The big difference between sustainability and resilience is that resilience has also recovery in it. It has many other things, redundancy and so on, but it has also recovery. It's not sufficient to preserve the water resources. The systems and their studies and the digital water and the digital world needs to move into recovery from any hazard and the impact from any event that may happen. We all know that climate change adaptation involves also extreme events, and the water infrastructure needs to be able to recover from these events, be it a severe drought or a flooding event. And that is part of water resilience strategy, and that shifts the whole world of water-related risks and how we're going to face them. And it's part of the digital transition. So, for the digital water, we need to face the challenges of the European Data Act, Artificial Intelligence Act, Green Deal, New Drinking Water Directive, and water resilience. Thank you. Any questions?
So thank you. We do have a couple of minutes to take one or two questions. So if there are questions, just feel free to unmute yourself and just ask the question directly to Lydia.
maybe a more of an observation rather than a question. But Lydia, I appreciate the reference, because it's important to make reference to this, to the importance of digital technology when it comes to some of the directives which are being proposed by the EU, particularly the new Drinking Water Directive, given that it's very important. It's increasingly becoming important with this directive, and also with other new EU or revised EU directives. There's a very important and big reliance on technology and information being made available, digital technology being made available for these regulations to be implemented effectively and to carry out the decisions necessary and as required by these directives. And I think the new Drinking Water Directive is a very important example, and a good example of the importance of the new revised importance of digital technology within regulation in the water sector. Thank you.
Thank you. I mean, indeed, the new Drinking Water Directive leads the way for new sensors, for new ways of collecting data, of combining information, and facing also risk, because we have now to face risk management, and risk management is much more complicated than just a threshold, which we measured in the lab.
So if there are no further questions, Lydia will be joining us even in our discussion. So at a later stage, I'm conscious of time, so I'll pass directly the floor to Daren, who will be presenting a hands-on example of a VR water network distribution rig that he and his team have developed as part of this WATERLINE project.
Okay, thank you, Edwin. I'm going to share my screen. Okay, so today I'm going to start a bit with defining a bit for those people who may not be aware regarding what we did with regards to the digital twinning aspect. So basically, what we will see today, there's two parts to it. There's the digital twinning aspect, and then there's the pedagogical learning aspect, because ultimately the aim of this model in the scope of this project is to be also a learning tool. So here we can see the three different levels of digital twinning. Ours is a kind of a bit of a hybrid between a digital model and a digital shadow. Why I'm saying this? It's because we started off with an emulated reality, so a real water rig, so a small water distribution network within a laboratory. And that has been successfully replicated as a digital object, as a digital model. However, configuration changes, the way it is built, configuration changes are possible. So if there's a change in the physical object, at request, at any point in time, it can be reflected in the digital model. So as you will see, the pipeline basically is a bit technical, but I'm going to go very quick through it. Basically, the system is built upon a modeling, an open source modeling software called DEPANET, where the network configuration is created with all the different properties of it, including valves, nodes, pipes, junctions, everything that goes into that particular model. So for example, we've got a pump here, and we also have included, characteristics like manufacturer pump curves, etc. And that is because we wanted to literally replicate the physical characteristics within our water rig. Having said that, as I already explained in the previous slide, the configuration can actually be changed. So changing the configuration would yield to a different 3D digital twin scenario, because this is not just a digital replica, it is also a 3D, it's built in a 3D environment and also deployed or deployable in to various platforms. So we've got a web version, we've got a desktop PC version, and we've also got an Oculus virtual reality headset deployment, which is much more immersive, obviously, than the digital, just the desktop version, because using gestures, using the various input methods within the VR scenario, you can literally use your hand to, for example, close and open a simple valve or manipulate certain properties of the particular rig. So in essence, what I just showed you now is this part over here, the first phase. Okay, so the design in EPANET. There's this is the uniqueness of what we created here is that we have managed to bridge EPANET with the Unity game engine. So basically, the EPANET network can be inputted or parsed. The technical name is called. We parse all that data, configuration data, into the Unity engine, whereby then on the fly dynamically runtime, okay, so not pre-built, the network is recreated in the 3D scenario, which I will show shortly. So for those who may be a bit more interested, we followed a lot of an agile philosophy. And the experts' input. So this was a close collaboration between myself as the lead developer together with my team, but in constant collaboration with our water expert, who is Dr. Rizzo. So basically, if it wasn't for Dr. Rizzo, for sure, it wouldn't have been possible to produce something like this, because we required obviously testing, a lot of testing, calibration, checking out of values, re-evaluating, ground truth testing with the real rig, etc. So the heavy lifting, obviously apart from the development itself, it was more on the actual calibration and making sure that the way our small water distribution network functions is replicated within the digital twin. And here it's how it's done basically. So all the values will be exported and then used to recreate the network. What you see at the moment over here is the first version. We call it the alpha version. Okay. It's the difference between, so a question that I've had a number of times is, why did you need to do this in a game engine? Can't you simulate the values, etc., within EPANET itself? Obviously, in EPANET, you can simulate what happens, but you will just get values, tables, maybe some charts, and that's it. We wanted this to be more of a learning tool, and as well with a high visual immersive content. This is a typical scenario that we used to work in, whereby all the testing and checking is done live while running the real thing. And following that, you will notice that we started to calibrate and value and understand how our network is actually behaving. However, this is just the first version that you see here. Eventually, we had another member of the team who assisted in finding and procuring the particular 3D assets to then produce our second version, which is Beta 1, which is a basic lab version, but we now have already some components which are basically look very similar also to the real thing. Following that, we continued advancing and adding more features, like, for example, pipes animation, which are semi-transparent, translucent pipes where you can view the flow of water inside. Also, pressure graphs on top of the pipe, which are semi-transparent, which are these ones that you see over here. And also additional features like sound, pump sounds, etc. Following that, we then proceeded in creating 3 levels of learning activities. The first level is a tutorial where our expert would explain how to operate the rig and understand different principles about water distribution, like, for example, the relationship between flow and pressure, and different other aspects, how to operate a pressure reducing valve, for example. So different lectures which help a beginner start off in this particular field. Learning tasks are more challenging because they will ask the user to perform a set of steps, and hands-on missions are the highest, more advanced, more challenging set of activities where the user is provided with a set of conditions that he has to reach without guiding him too much. So kind of you need to achieve this kind of balance in the network, for example, a certain pressure at certain points, etc. And as I mentioned already, the solution has also been deployed within a course within a virtual learning environment, which is the WATERLINE Moodle platform. So in a nutshell, that is how it works. However, what I will do now is I will do a live demo of the experience of how it would look. For example, I'm going to, for the purposes of this presentation, I'm going to make use of the hands-on missions. Okay, so we got, for example, basic operations, establishing flow and pressure. So if I go into mission 2, for example, this is our rig. The simulation is running. You will get a guide on top over here of what you have to achieve. So here, basically, we have...
So sorry to interject, but we're not seeing the screen.
Sorry. Okay, now
yes,
better.
Yes.
All right. During the presentation, okay, now? So let me share with sound. Apologies. So let me share with sound. Okay. So this is basically the experience. So let me go one step back. All right. So this is the main menu, where you've got the different activities, and we can click on hands-on missions. And for example, choose mission 2, establishing flow and pressure. On top, we've got what we need to achieve, basically our mission. We've got some assistance in viewing identifying the flow meter and pressure meter that we need to basically look at. And I'm going to start off with switching on a pump. Okay, and you should be hearing the sound as well. And switching on the pipes animation. So once I switch on the pipes animation, you will see that I will get an animated digital model where we can view how the flow and the pressure changes whilst I'm operating at different pump speeds. So once I achieve that, I can readily go and check my values over here. So in this case, what I'm going to do is I need to reach 1585. So I'm going to start with establishing the flow, and this was it's one of the simplest missions where I have achieved roughly 1585 liters per hour with 1 bar of pressure at this particular point over here. However, the way the system operates, you can also choose a free exploration. So if you want to literally experiment with the particular with a particular configuration, like for example, opening a pump and then closing off a certain part of the network. So for example, right now I've closed the second and third parts of the network over here. And now the water obviously is flowing through this particular loop. We've also got missions, not in this mode, where we can sense, for example, abnormal pressures, and with the user being alerted to such a situation. For example, if I go back here and go into whole rig, or else let me go and do the learning tasks so that I do a small demo of the learning tasks. So over here, we've got this particular scenario, and I need to follow those particular instructions. So set the pump to 50%. Okay, some of them are beginner level. Others are much more complex to carry out. So here we're saying, look, read flow meter A and pressure meter C. So I need to navigate towards this section here. Okay, and as you can see, I have a flow of, I can switch on always the pipe animation or switch it off, and I can readily experience. For example, here I've got 1250 with 1.2 A bar. Now I'm being asked to open valve B, so click on it, turn the handle, and I've opened valve B. We have seen that roughly the pressure has remained the same, but the flow has been now divided because we've got two different routes where from which the water can pass. When ready, we click evaluate, and we can see that in this case we have pressure, no changes the brand, no pressure inflow and flow half, and that is the correct answer. So this is in essence a typical, just showing you a few examples here for the purposes of today. But this is in essence how we turn then this particular digital twinning experience into a learning activity. I think that's it from my end, Edwin.
Yes, thank you, Daren. We do have time for some questions to Daren, if there's someone who'd like to ask some questions. So if not, I have a question which I would like to direct to Alex, if it's okay, Alex. So given this from your expertise in this area, what is the advantage of using such systems over the physical environment? Darren called it the emulated environment. What would you?
Angela, I'm going to try to share the screen to answer.
Sure.
Just tell me if you can see the visual.
Indeed we are.
Okay. So this is, to answer your question, Edwin, this is where we started. This is what we started off with. This is the physical layout. And we call it an emulated water rig or water distribution rig. Basically, it's a replica of a full water distribution network, what you would find underground, thousands of kilometers of water piping, valves, mechanical valves, automated valves, PRVs, mechanical helix water meters, and the whole configuration. So this is a small scale, fully functional water distribution network, SCADA controlled as well. So this would be controlled by a SCADA. SCADA means supervision, control, and data acquisition. And this is the actual device itself. Now, the whole project was instigated because of COVID. So whereas before our students, and when we say students, we're talking about level 4 students doing an advanced diploma in environmental sustainability, to a degree in environmental engineering, which always contains a strong component on water, to even our masters in integrated water resource management. Quite a few of these programs are in collaboration with the Malta Water Services Corporation. The problem was with COVID, access to the physical setup was no longer available. Not only that, but even post-COVID, some students, international students, distance learning students, didn't have access to the physical network. What Daren has shown is a digital twin of the physical network. It's been modeled in line with the physical network. It works in exactly the same way in a digital fashion. It has the same parameters, the same challenges, the same setup, the same components. So it gives a very similar learning experience without without the problem of access to the physical setup itself. And we've always discussed, Daren, myself, and even you, Edwin, what are the options that a student can take? I mean, the ideal would sometimes be that a student comes physically and experiences the physical layout, getting to feel what it's like to change a valve manually, electronically, what happens as a result, pressure-wise, flow-wise, noise-wise, vis-a-vis a student having both physical access and virtual access, vis-a-vis a student having only virtual access. And we wanted to build a system that gives the same, as much as possible, the same advantage to these three types of students. So the product that Daren has shown is an extremely strong digital replica. That's why Daren calls it a digital twin. Digital replica of the actual physical emulated environment. We call it emulated because it's a small scale version of the actual. It's not simulated, it's actual but small scale. So the digital version should give us an immersed learning experience. One of the things that Daren mentioned was sound, noise. As a water engineer, we don't just monitor pressure and flow. Even noise is a very strong parameter in our study of a water network. I mean, we look for leakage via noise, via using accelerometers, using correlators. We notice if a valve has closed properly because of noise. So the parameter of noise is a real parameter when studying and managing water and water efficiency. And Daren has created that sound-wise in a very similar fashion to this physical rig with its variable speed pump and all of the parameters that go into it. So the objective was to give students, anything from an undergraduate to a postgraduate student, a learning experience which could be as close as possible to the physical environment, possibly with some advantages, because nowadays, I mean, the digital world is the world we live in. So sometimes, I mean, in many cases, when you have engineers, water engineers controlling a water network, they do it via SCADA, supervision, control, and data acquisition. Sometimes not even going on site for many days, to put it that way. So sometimes, in some way, one might say that the digital twin is just as much reality as the physical network in itself. Not sure if I answered your question, though, Edwin.
And yes, very indeed in depth. Are there any questions, maybe, or reactions to Alex's comment? I do have another question for Daren, relating to this to the system in terms of visualization. This tool helps water engineers visualize actually what is happening in the water distribution network. We have developed also virtual reality to support in this visualization process. Can you maybe elaborate on this, and how can also this particular technology help maybe in looking at larger systems?
Yes, thank you for the question. Basically, I'm going to reshare a bit my screen. Basically, what we tried to do here, and from the piloting with students, etc., we also captured feedback to this level. Visualization and immersion is something quite complex, so there's no simple answer actually to this question, but I can give some principles which are heavily important. In fact, nowadays, even in our institute where we teach digital games development and similar serious games, because basically you can also interpret this as a serious game. However, the immersive aspect is something which needs to be intuitive. So there are certain elements which, for example, in the desktop version, we are viewing values, for example, on top over here. But when it comes to a VR experience, we have tried to create a physical world which is very similar to what we have in reality. For example, in the case of the VR platform, in the VR deployment, once you wear your headset, you will view 3 screens hanging from the ceiling, and everything is represented over there. That is to avoid the user from distracting him from a real-world environment. So visualization, for example, and the manipulation of valves. That is something actually a bit tricky, because you have to be careful in VR. When we talk in VR, what frequently happens is that if it is cumbersome to achieve an input, like for example, turning a ball valve, or reaching out to change the pressure valve. All right. So what will happen then is that the user will be either distracted or demotivated, or say, look, why am I using the VR ultimately? Why don't I use the desktop version? In fact, many times, even when we do our training, now we're quite used to it, where we try to first introduce the rig to understand what it is, how it's set up, etc., through this version that you're seeing now, and then proceed to the VR. Because ultimately, what we don't want is that we have a user who is overwhelmed, for example, and this we need to be very, very careful of. From experience, I've learned that immersive technologies like virtual reality can either go good, you can reap a lot of benefits by having a truly more natural, more realistic experience, or else people wouldn't view much value in having such a visual environment. So it's a question of tying visualization with user experience. And I believe that the first priority should be user experience. And that's where it can get tricky. I'm being very open here in mentioning this, because it took us a number of iterations in actually getting it right and having it presented to our learners in such a way that it is not cumbersome or have a high learning curve to achieve it. For example, one feature that we added towards the end, this was quite recent, is, for example, having an interactive guide to guide the users on how to actually interpret and use the different parts of the digital model. So these are very important aspects which the experience of this project has taught us. Hope I've answered your question, Edwin.
Yes, thank you, Daren. So I would recommend that before we progress to our second part, we'll have a short break, just some time to grab a coffee and stretch your legs a bit. And I suggest that we reconvene back at 3:10. In the second part, we shall be opening up the interactive virtual forum, and also listening more about the ideation project about digital twinning for inland waters. So thank you, and we'll see you later on. So welcome back. And before continuing, I've just been informed by Daren. Daren will be sharing the link even to the water rig. So if you would like to try it out for yourself during or after the sessions, Daren will be leaving. Actually, he just did it now. He will be leaving the link of the actual rig that you can test out. And once again, as highlighted by Daren and Alex, that those are the real values. So that's a fully functioning water rig. But beyond further ado, I would like to start off this discussion. In the discussion, basically, we will be covering three main themes. One is discussing industry needs and commercialization opportunities when it comes to digital water. Also, those of you who are not too familiar with the concept of digital water, during this particular panel, we will be trying through actual examples to highlight even better more pragmatic solutions of digital water. But also the idea is of the event is to serve as an ideation. So one of the things is that we're trying to show example to show even the doing of how to create these solutions. Another thematic area will be also looking at the current research and also national policies. And also we shall be closing off with some contributions from all the members. Starting off from Alex. Alex, you've been in industry working in the water industry with Water Service Corporation for a number of years, and then in the past years you moved on to a more academic role. But from your viewpoint and your current viewpoint, what are the predominant challenges confronting water industries today? Now that you are in a point that you are a researcher in this field.
It's a good question, Edwin. Things have changed and changed significantly. I started off in the water industry in the late 1980s. And the biggest problem we had, which was actually mentioned today by Lydia, was data and data sharing. And that I think is fundamental to digital water and to water efficiency and all of that. Those days in the late 80s, we're talking 30 plus years ago, we were in a situation where we had very little data, some data gathered manually and used sporadically. We used to close off supply to half of the island on a daily basis. So if we fed water to Zabbar, we wouldn't give water to Masa Shlok. It was that bad those days. One of the things that the Water Services Corporation those days did very well, and does even more strongly today, was seeking knowledge, communicating. Lydia mentioned this today, and collaborating. In actual fact, I think possibly one of the best moves they made way back in the early 90s was joining the International Water Association, the IWA. And in the IWA, and they're still members till this very day, the IWA gave the water services many ideas and kind of insights and knowledge on how to manage water, how to manage water efficiently, how to create water balances, infrastructure leakage index, and many other aspects. And gradually, the water authority in Malta, because in Malta we only have one water supplier, the National Water Services Corporation. It's very unique in that all of the world, you'll find multiple water providers, water utilities, and even in Cyprus, which is like Malta, even in Luxembourg. And Malta is the exception with only one main water system provider. And what the water services did very intelligently those days and built upon it from strength to strength, I would say, was appreciating the value of data. In those early 90s, data began going digital from an early age. I'll give you a simple example. We used to start by recording master meter readings, zone inlet flow readings manually, then data loggers are giving us digital data, night flows, which give us leakage values, which give us zonal information, and so on and so forth. So gradually the water utility in Malta built a significant strength in data management and in data analysis. So much so that nowadays, if you look at the water services, they're very much GIS based, where you now have layers of data, layers upon layers. You have a network layer, an elevation layer, a leakage layer, a water billing consumption layer, and you can look at bits and pieces as the need demands. That's being updated on a daily basis with new data, so there's a lot of focus on data gathering. So I see a very strong correlation between the value of data, as Lydia mentioned, and the value of collaboration when it comes to data, because many water utilities have their own pockets of best practice, what works and what doesn't work. And when water utilities collaborate, and many don't, some do, when they do collaborate, it's sharing of best practice. And it allows a water utility to be the forefront in some aspects and to learn from other water utilities in other aspects. And that's where the International Water Association was extremely fruitful and supportive of the learning process. There's also the European Water Association, but the IWA is a bit larger and I think a bit stronger. There's also the American Water Works Association, which is quite strong. So that was a development that has never stopped. Nowadays, it's not only digital water. You have smart metering, you have GIS-based data, you have decision-making aspects going into data vis-a-vis creation of energy. We're talking about the green bond scheme, where reservoirs are being used to host solar panels. So it becomes a very complex affair. And I think a conclusive comment from my end would be this. And we're talking about now over here water utilities. So this is heavy engineering industry, not commercial or pure industrial water. This is heavy engineering industry. The water utilities are part of 4 factors that make up heavy engineering. It's water, energy, telecoms, and transportation. So it's a strong industry. It's a very important industry. And I think if you look at what made the national WSC, Water Services Corporation, that effective at what it does, obviously everyone has weaknesses, but in general that effective was the appreciation of data, the management of data, creating GIS-based data and all of that, and the constant collaboration of best practice. And even if you take the water services vis-a-vis MCAST, the collaboration, that's an extension of best practice going into research. And you mentioned WATERLINE, Medun. There's other research projects taking place at the moment. One of them, which is a very interesting project in collaboration with the Water Services Corporation and MCAST, with the University of Enna in Sicily, and with Malta Enterprise, and a small NSME, Westrade, is looking at water harmonics and water transients, pressure transients. Using a unique type of pressure logger, which very carefully looks at pressures within a water network. If there's a slight spike, it goes into zoom mode, it expands and goes into microseconds of analysis, looking at how these pressures affect the network, its integrity, how they affect revenue water metering, and all of that. And that's another aspect of data. Now, obviously, what Daren has done and his team is taking this to the aspect of the digital twin of virtual water, where you can understand and work from a distance, because nowadays that's become the next most important thing, not being so physically involved, because it's not always possible for us to be so physically involved with the water management scenario. I don't know, Edwin, if I've managed to hit upon the point that you asked about.
Yes, in fact, you've opened up on 3, I think, things that I'll be picking up on during our discussion. Firstly, the research element, which I'll be putting aside at the moment, but I think it deserves a discussion on its own. The data-driven insights, but now that technologies available to do something with that data, it would be interesting to see what Watershare is currently working upon and how they are utilizing emerging technologies to use this data to actually give a better service. But also the third dimension that you've highlighted is the international dimension and the context that Malta is working in. And here I would like to rope Lydia back into the discussion, given her heavily involvement on the international sphere and even the various organizations she works in, and I would like to ask, from a European particular context, to what extent, Lydia, to what extent have industry succeeded in adopting smart water solutions, and why so?
I think there are different levels of adaptation. We have utilities which are very advanced, like Malta, and in locations like Malta, but also in other countries, for instance, in the Netherlands, even in the UK, partly, not all of it, and some such countries, and also in other countries in big cities. For instance, in Greece, I come from Greece, we have adaptation of smart management, partly at least, but advanced in the big cities. When we go out of this, when we go to the smaller communities, which are multiple in Europe, thousands, we see a very low level of adaptation of smart technologies, very low. We are lucky if we find meters, not smart meters. And this, I would say, different levels of adaptation is characteristic in Europe, and I think it's due to the big fragmentation, because the small communities don't have the potential to do it. They don't have the capacity. They don't have the engineers. They don't have the people that know what they're doing. So they necessarily stay behind. And we have major issues, as I said, in multiple small communities in Europe, but not in the big ones where the smart meters have been gradually being more and more adapted. Having said this, the distance, I think the time distance between innovation produced, I don't know, from an EU research, an accelerator, an innovative SME, be it a sensor or a smart meter or whatever, to being implemented really is about 10 years. I think there is a rough distance of about 10 years from the moment an innovation is being researched or being in project or being funded to the moment where the most advanced utilities are going to adopt it. And that's on top of the big distance where we have with the small utilities across Europe.
This point is very interesting to note. And moving on this point is, okay, so we have this 10-year gap. From what I could understand, Water Services is using some in-house development when it comes to water services. Possibly a reason is to close off the gap, given that it is done in-house. Owen and Claire, from your experiences at Water Services, what are the key digital technologies currently being developed or adopted to enhance water service delivery and operation efficiency?
Hello, Edwin. So basically at Water Services currently, the main focus of the development team is how we can use AI in order to facilitate the work done by our fantastic engineers, basically. Currently, we are using data from different kinds of sensors, which we get from SCADA, as well as our GIS architecture, in order to be able to predict what water we will be using, what the amounts of water we'll be using from our different sources, in order to have the best blend that we can have with the least cost to produce this water. So effectively, this AI is helping our engineers decide which sources to use, which sources to turn off, and if it's much more useful to use groundwater as opposed to ROs or vice versa. And that helps our engineers have a much more concrete decision that they can take basically on a daily basis and sometimes even more.
Thanks, Owen. A further question to that is, what has driven possibly water services of adopting this approach rather than, you know, buying the service from? Is it because the service is not available, or?
Basically, you can find anything if you custom development at the end of the day. But since we had the skills in house and we know how our system works, it was much more easier to do it ourselves, as we have the learning part of how the system works already understood basically. So that part of the problem was already conquered.
Okay. Very good. Thank you. I'm aware also that at the Energy and Water Agency, they have even developed some digital solutions and have used some digital solution. But before, I would like to ask Lydia for a contribution.
Yes, I mean, it's true that water utilities are developing software in-house, which they use, and that poses the other problem now that we have the standardization and the data exchange and the need for collaboration with external services. There's no standardization, and it's very hard to transfer data or to use data from other sources, or to even to install or implement a new version of software that comes from another source. And this is a major problem. The legacy systems, that's what we call the software that already exists in different utilities, that needs to be updated, that needs to be synchronized, that needs to receive data from other sources, and this is very hard to happen. The FIWARE platform, which was funded by the Commission for every kind of data exchange, not just for the water sector, it started with telecommunications, tries to solve this problem, the compatibility with legacy systems, one of the problems. So it has what they call the context brokers, which is like adapters of data coming from different sources so that can exchange and can legacy systems can talk with newer systems that are in the utilities. So yes, the in-house development is perhaps a blessing for the utility, but a nightmare, or I would say a headache, when it comes to be synchronized or be used with other external data. Unfortunately, the future is with data that come from other sources, even if they come into the utility. So in-house will not be the best way to do it unless in-house rules are being followed when it comes to data exchange. And that brings us also to standardization for interoperability, again, which is a must.
Yes. And one thing that this prompts an earlier discussion that Alex was sharing an experience earlier on this morning in a different meeting, where he was discussing even the vulnerability of being dependent on other organizations because they have the data. I don't know, Alex, if you'd like to share the example you highlighted from the UK.
Yes, sure, Edwin. I mean, because
this morning.
I mean, I have two thoughts. I mean, you can create in-house software and in-house systems which have strong integrative value, using components of integration of data collaboration that can be shared with others. So one can create in-house and still create in-house softwares and systems that are accessible and shareable with international standards and parameters. It has to be done intelligently. Something that I definitely agree with Owen is that some problems are very specific and particular. I'll give you a simple example. I mean, if you take Malta, because of our roof tanks, we have extremely low flows. We use particular types of water meters which are accurate only at the lowest of flows. As Lydia mentioned, some companies don't even have water meters, let alone the accuracy needed for measuring flows below 1 liter per hour, which is dripping water. And the ways to measure that water are specific, so the solutions sometimes have to be specific. Obviously, one has to be intelligent enough to have an integrative dimension, being able to link and to share systems and data sets. The example I gave this morning, Edwin, was actually when I was working with water in England, Thames Water. No, I was working, my apologies, with Wessex Water. Next door to us was Thames Water. And they had a huge problem in that they had outsourced their network management, their planning, their sketch, their schematics, their velographs to a private company. So their water distribution networks were being mapped by a private company who actually managed to take ownership of the maps, of the plans. Till this very day, to a large extent, the Thames Water is a captive to a couple of contractors who have all of their data. So a good water utility will take care of its data very intelligently. Ideally, look at best practice, look at collaboration, look at sharing, look at integration. But very, very often one has to do it oneself. So I'll give another example. I mentioned the Blue Drop project we're doing in collaboration with a university in Italy and with the water services. This is looking at pressure transients. Very few water utilities, if any, bother even have the interest to look at these minute pressure fluctuations which dictate how a water network operates. They affect leakage, they affect water supply, they affect longevity, they affect, we found out, the performance of the revenue water meters. So some things have to be done in-house, and they have to be done by the people who learn from the implementation and then remain as the experts within the water utility. So a good water utility is a learning organization. I've seen some organizations outside the island where the opposite of a learning organization is a forgetting organization, a failing organization where expertise leaves, no new people of adequate skills come in instead, and you forget more than you learn. And the trick is to have good people in-house that implement research projects, implement developments, learn from them, keep the learning going, keep the data kind of building up in strength and in structure. And moving from one aspect to another, always looking at best practice with other water utilities, talking to other water utilities for what works on a European dimension, on a Mediterranean dimension, which is quite different from the European dimension. I mean, go to Holland and you have excess water everywhere. Last summer, Holland was underwater. 2/3 of the island of the country was underwater. And in Malta, we barely have enough water to survive without using reverse osmosis water to be able to support people's needs. So sometimes complex problems have to be solved in complex ways by the people who need to learn from the problem, in my opinion.
Thank you, Alex. You've hinted at scarcity. I would like to open Michael now from the Energy Water Agency. Michael, can you share whether there are local policy strategies or initiatives that your organization is leading specifically to address the use and promotion of digital technologies in the water sector?
And the mic, the speaker,
Microphone.
Michael.
Sorry, apologies. So thank you for the question, Edwin. From a policy point of view, the water policy point of view, it's very much guided by what is laid out in the Water Framework Directive. And one of the, I would say, key pillars of the Water Framework Directive and the subsequent management plan, which is then developed for the management for Maltese Islands, the River Basin Management Plan, is, I would say, efficiency. So if I would highlight one policy aspect, which is very important also when it comes then, and it lends itself nicely to the importance of digital technologies in the water sector, I would say efficiency. And this is something which is very much promoted within the Maltese Islands. I was very happy to hear the examples provided by Alex on the work done by DLT over the years and also the demonstrations done at MCAST and also by Owen and Water Services when it comes to the use of digital technology. So it highlights Malta's commitment, because it has always been a policy decision to be as efficient as possible in our water cycle, particularly given our reliance on production. But I would say that apart also from the work done by the utility and academic institutions, there's also the very important aspect of efficiency and the use of digital technologies to improve, adopt, and have this efficiency in other parts of Malta's water cycle. For example, the way we use and interact with water on a daily basis. So there are maybe minor changes which one can do, which can lead to and utilizing digital technologies, which one can utilize to be more efficient in their day-to-day use of water at their home, for example. Nowadays, there are applications which you can download on your mobile and help you be more efficient in your water use cycle at home. There are much more efficient water appliances now, and there's also been initiatives also with collaboration by different government entities to promote more efficient water using technology and equipment at home. We're also looking at possibly in the future and possibly in the coming years the adoption of some form of water efficiency label to even further promote efficient appliances and water using devices within our homes, given that the water we use at our homes is one of the most important water using sectors in the Maltese Islands. But then there are other aspects to, I would say, efficiency within the water cycle. As you are aware, in Malta, the agriculture sector is also a very important water using sector, and given this emphasis on efficiency, and this has always been a very important aspect when it comes to water use policy. So we have to do as much stuff and do as much and gain as much economic output out of a single drop of water. This has also been the approach within the agricultural sector. So this explains also why within the agricultural sector, from a water use perspective, there has been quite a good appreciation of, rather than let's not call it maybe digital technology, but also to innovative technology or more recent, more water use, more efficient technologies. So that explains why nowadays a lot of our agricultural holdings are equipped with drip irrigation. Some of them are also now looking into smart irrigation systems. So nowadays there are farmers who also utilize dedicated apps to be able to manage better their water cycle, their water irrigation cycles. Some of them have also it's not yet widespread, but this is slowly gaining ground, also through work done by the agency through information campaigns, through the use of sensors, either water content sensors, for example, within the soil matrix, to allow farmers to better understand when actually to do irrigation, depending on obviously the weather conditions, depending on also the soil conditions, and also the crop being grown. So that is also part of the, I would say, the key pillar from a policy perspective, to focus on being efficient in the limited resources that we have. Maybe one other aspect which I'd like to highlight, which is also very much supportive of policy development, water policy development, is also a greater appreciation on the importance of real-time data. So as Alex mentioned, there's over the years, over the last decades, there has been appreciation of the importance of data, but now with real-time data, real-time understanding of the operations, for example, when it comes to utility perspective, but also now looking at it from a policy perspective, a real-time understanding of the status of our water resources, it's a very important and I would say a step from a policy perspective. So nowadays we're in a situation where we can look at the status of or get a much better understanding of our water resources in real time through the deployment of sensors which are transmitting data, which can be accessible and viewable in real time. So that is having real facts which are available on the fly is an important outcome for sound policy development.
Thank you, Michael, for these very great insights. You've mentioned a lot of elements from looking at the bigger picture, emerging technologies, and also, you know, less emerging technologies. So technologies like apps that are available to us. So when we think of digital water, it might also be something simpler that they're not. And you touch base on the parts of the water cycle, and most importantly, I think a key element that you discussed is the efficiency. I would like to turn to Daren. So moving on Michael's bigger picture concept. Daren, can you share some examples? I'm aware of some examples that you've worked on in the past of digital solutions relating from the environmental or infrastructure sectors. What type of projects did you work on this? And I'm mentioning this particular question because I'm aware that some of the people who joined this forum are also coming from the environmental sector, not specifically to the water. So maybe this could also be used as an ideation event for them to even think about how to digitize their sector.
So yes, first of all, one would have to see which motivation. So it all starts with motivation, and a number of projects I've worked in, like with I see someone here from the Environmental Resources Authority, for example. We did work in collaboration with MRA at that time, nowadays Climate Malta. So and other collaborations, like a project which we have recently been awarded together with an NGO like Zibel. And one underlying principle that I always notice is that many organizations and in industry, they look towards an increased awareness. So that is one particular motivation, which I've noticed throughout. For example, in a project which we had a student working on together with the Environmental Resources Authority, we created an augmented reality, readily accessible app to monitor air pollution, where basically the different air pollution stations and tubes where the data was collated. It is read by the app and augmented on your smartphone. So basically, you just raise your smartphone and you can visualize, you know, at a particular point in time, or else through a kriging map, viewing and having a better visualization than actual charts or tables, etc. So that's one particular motivation that I've understood that various organizations look towards. Then there's the aspect that Owen mentioned, the use of AI, which is becoming increasingly important. For example, with work that we've done, for example, in collaboration with the Planning Authority, to facilitate building boundary extraction using AI. So laborious processes now we're talking. So making processes more efficient, doing the dirty work, I like to call it the dirty work, faster and more accurately. The third that I've seen is getting, and this is in line with what Owen mentioned, is getting insights, more valuable insights that you didn't have before. So to assist decision making. So actual, and I view this as the most important, to be honest, because a good decision making based on good data, I think is becoming critical in the world we live in. We're surrounded by so much data that to make sense of it, you need to have a good either AI or some kind of data science solution to assist you in actually making sense of all that data. And if you don't do, you risk on to make bad decisions, basically. So from an industry perspective here, I'm talking more than from an educational perspective, which was the what I showed before. I think these three particular aspects are particularly important, and the examples that I've mentioned, I think fall under one of these particular three founding pillars that I view as what's currently happening.
Thank you, Daren. So moving with this, you've hinted briefly, you mentioned student projects, research, and so on. I would like to briefly touch on the importance of research in this particular sector. Roping them mostly Michael and Lydia, starting off with Lydia. Lydia, to what extent do you see research findings to be transformed into practical processes and products? And what factors can contribute to the successful or limitations of this translation?
That's a very good question that doesn't have a uniform answer, as I said. I think that the innovators are developing innovations, that's good. But for the utilities, for the water sector as an industry to adopt them, there are big differences. There are the first thing that is like there are various barriers. The first barrier is awareness. I mean, they don't know what it's out there and what they can adopt successfully. So campaigns for awareness is the first step for adaptation. The second has to do with regulations. They will not adopt something, for instance, to measure water quality unless there is a regulation that makes them do it. So I see the role of the Commission in promoting frameworks and promoting also various directives that go at national level, and then they get adopted. So they oblige the utilities to do something about it. But also the third has to do with procurement. A lot of utilities have very strict regulations on how they're going to purchase or install the new innovation, and that is a big barrier, because procurement regulations sometimes are restrictive when it comes to how to get a new innovation and install it in the utility. So even if they know it, even if the regulations are there, procurement becomes another big barrier, an obstacle. In some countries, it's easier. For instance, in the Netherlands, it's easier for the utilities because of the legislation to adopt a new innovation. In other countries, like for instance, Greece or Cyprus, it's very difficult because they have all sorts of legislations, and these procurement regulations, they have been made for one purpose, all right, so as to have some sort of standards to follow. But when it comes to innovation, it's very difficult. For instance, they cannot purchase, for instance, or hire someone to install a couple of sensors to see how they work and then implement them in the network, because there's no way to do it legally. They can go, for instance, as utilities, as case studies in one project to try something, but when the project finishes, there's no way to continue this. And this has a lot of problems that cannot be resolved centrally from the Commission. It goes down to the individual countries. And there, unfortunately, we see also, not just for the water sector, that a lot of the legislation about procurement and the rest is very outdated. It's not made for the digital world, unfortunately.
So, Michael, when it comes to policy now, so how can we bridge the gap between research outcomes and policy implementation?
So bridging the gap between research and policy implementation is not an easy job, I would say, because it's very often happens that unfortunately research or policy development are not aligned, so to say. But in reality, they should very much be, because in reality, policy per se is an exploratory science in itself. So it needs research. Policy needs research for effective policy development, and I would say vice versa. I mean, research on its own without contributing to policy would not really lead to valuable, I would say. It's very important to ensure that this gap, the potential gap that might exist, is at least minimized as much as possible. I believe sometimes this happens because obviously it might be that both sectors, so to say, are not speaking the same language, or there is not sufficient communication. One way how to go about it, I would say, is maybe through the use of pilot projects. I see pilot projects as one way how the research and policy can come together to ensure that what is being proposed, either from a policy perspective or from a research perspective, can have an important outcome, a tangible target. So it's very important for research to be in touch with policymakers to see that what at least part of the research which is being proposed can eventually have an important output, which is maybe relevant for management institutions, and most importantly for the general public. I would say that is one of the key ways how researchers can get across to policymakers. So how is that research relevant, or can be relevant, or can be a change maker for the general public when what is being done, or for the general environment, not just the public, when that research can be practical and relevant from that aspect, that will get policymakers, I believe, more interested, definitely. And then it can be the other way around. So it can also be policymakers coming up with ideas or approaches, or wanting to test out some approaches. And then obviously you would need then the research capabilities of academic institutions and researchers to test things out. So that is why I mentioned pilot projects could be a very important, or one way, it's definitely not the single way, but can be a one way how we can go about improving, bridging the gap between policy and research or academic institutions, to make sure that what is being tested out can actually work.
Thank you, Michael. We're reaching the end of because we're constrained, unfortunately, with time. But I think an important element that needs to be touched upon is even how to design these solutions. Michael, you mentioned pilot projects to support. I would like to turn on to Claire and Owen to maybe give us some insights and maybe walk us through how WSC approaches the development of digital solutions. What internal or external inputs guide the process?
So basically, we take the same approach normally with digital solutions. It usually starts with an idea from the client or whoever. It could be an internal person asking for a solution or for a project. And what we do is we go through the requirements with the person. We come up with a document so that it's agreed upon from both ends. And then we start with mocks or UX designs to give a better idea of what we are aiming for and also to see whether the client is in line with us. And then the development part starts. Normally, it is divided in different phases. With each phase, we provide the testing after the development is done. There's a testing phase, and the client is asked to sign user acceptance testing. And we proceed until we reach the end of the project. After that, there's also the maintenance part involved, where we stay actively involved in the project with enhancements and arrangements whenever issues arise.
So basically, just to add to this, even though our clients are internal users, at the end of the day, we still treat them like it's a full software development house. So at the end of the day, even if when they usually come with an idea, they want everything. They start imagining a rocket to the moon, but we sort of lower expectations. We have our resources and our knowledge, so our aim was also to lower expectations and also provide a solution which makes them happy at the end of the day, and also make sure that what they are actively trying to reach with our solution, it helps them and it helps them do their job easier and much more efficiently.
And also we try to standardize as much as possible so
Yes.
that if a similar solution is being proposed by another user, which may be from a different section in water services, we can provide or make amends with that particular solution.
Thank you, Claire and Owen. You brought quite some memories over the last year and a half when Daren, myself and Alex were discussing this with two different worlds apart. I was the in-between person trying to get Alex to understand more Daren, so I was the sort of person.
Yeah.
And I think that's a critical point that Owen, you mentioned lower expectation, and I think that's important because
Yes.
one of the things is that end user think that IT can do everything, but at the same time, from a technical point, sometimes the simpler of things might be the
Yes.
most complex. In fact, this is one thing that me and Daren constantly have discussions on. It's you really need to appreciate coding and development to appreciate what a feature could be, because some complex feature might be developed in 1 hour. Something which really looks simple, it takes you hours upon hours upon hours. So
And
Yes, go ahead.
especially when it comes to AI, the perspective of a non-IT persons is that this AI can do anything with a click of a button and it will do everything. And that was our major part, especially in our AI project, that listen, although AI can do a lot of things, it's good to contain the expectations as AI, at the end of the day, it's still a tool like any other tool, and it has its flaws like any other system.
Indeed. And as you mentioned also, standardization documentations, I think, are critical.
Yes.
We've sorry.
Even the documentations are really important, as if even for people that comes after us, they have a concrete documentation as to avoid having a system which no one knows how to modify, no one knows how to maintain it, and it also ensures longevity in our applications and ensures that water services keeps on thriving at the end of the day.
Owen, Claire, I thank you. We're just about on time, but at 4 hour discussions had to end. But I really want to conclude the discussion by inviting Alex, Lydia, and Michael to include their final comment on what they believe is the single most important step that in Malta we need to take, whether it's policy, research, industry collaboration, development of technologies. So their final comment. Alex, can I start with you, please?
Yes, sure. I was just thinking, I mean, some very interesting points that Michael mentioned. I mean, policy guides research, and in return, research influences policy and even standards. And also, when it comes to the implementation of research, following policy or guiding policy, if you look at European research levels, the TRLs, the technological readiness levels 1 to 9, I think, the higher levels are the applied research, the kind of implementing known technologies, known solutions in a new scenario. And that's where the applied research really takes place and needs to take place, often at pilot level. And Michael mentioned pilot projects. Those are vital. Seeing if a new technology works in a new environment, it goes from everything from data logging to AI to processes and many other things. And I think that's where the learning really takes place. I mean, getting hold of a best practice, a technology, trying it out, learning from it. If it works, extending it, working in line with international standards and international, I mean, for example, WSC has adopted ISO standards for the last 15, 20 years, if I recall correctly. So there's an element of standardization in what is done, but the solutions often have to be unique. So, I mean, at the high TRL levels, looking for applied research solutions that work. If they work, extend them. As Owen mentioned, then retain the information so it can be shared to other people, and then move on from one strength to another.
Thank you, Alex. Lydia, would you like to share your final, maybe?
Well, I need Alex is right. He touched a lot of things. I'm going to say something different. Capacity building through education, through the training of the operators. I believe in capacity building and training a lot, because if the operators understand the usefulness of the digital tools, then they're going to require to the managers, and the managers to the government, and the government will be obliged to change things. But if they don't know, and there's a big difference between the operator and the manager, the operator may know, but the manager needs to understand this. So I would say capacity building and training, not just for the operators, but also for the managers of the utilities, which are not engineers many times. So that's in other words, that I would say at top of Alex.
Thank you, Lydia, for your time. We really appreciate you being here. And you're very insightful, both European level, but also pragmatic examples as well. And finally, some concluding remarks, Michael, from your end.
So, first and foremost, I'd like to make the point that I fully support what Alex and Lydia have said in terms of their concluding remarks. I think they're very valid observations to which we need to take home with us. But maybe another point which I'd like to add is on the importance of industry collaboration, being with academia or with policy institutions, because let's consider Malta's case. And given our context, in most instances, the options and solutions that are required for our issues, for our problems, already exist, either in other European settings or around the world. It's just that sometimes there's the difficulty. Sometimes it's also as a result of the limited market that we have for that technology, for that that solution to be present and be profitable or marketable in the Maltese Islands. So maybe that's why the importance of industry collaborations to see how that can be adapted for our particular setting and to be suited for Malta's specific conditions. So that what I'd like to stress here is that rather than reinventing the wheel, in our case, it's what adapting that to our conditions, because options and solutions and good practices exist, and we can appreciate them and then see how to incorporate them. Thank you.
Thank you, Michael, for this insight. So we'll have the last 20 minutes or so, and I would like to ask you if you have any questions to leave them till the end. We'll have a short Q&A session if there are any questions, but without further ado, I'd like to ask Eloisa to give us even some insights on the project they currently have started, which also relates, as I mentioned before, on digital twin. So it's a really applied project on digital twinning. There's Lydia also who's involved in this. So I'll kindly ask, I'll give the floor to Eloisa.
Thanks, Edwin. Good afternoon, everybody, and thanks for inviting me to introduce you this project, because I think that is very related to what is the aim of this meeting today. And actually, I learned a lot from all of you, and I share the majority of the thoughts. And also I want to say that I'm working in Cetaqua, that is a water technology center located in Barcelona, that is part of the Viria Spain group. So we work a lot with utilities, and so we know how is difficult the digitalization from this point of view. Also in Spain is not so easy like in other countries. So we have a lot of work to do, but I think that there are projects that are just giving the opportunity to do that. That is a very good point. I have the pleasure to coordinate the ideation project. That is a European project that, as Lydia was saying, one of the gap that we have is the fact that from one side we have inland waters, from the other side we have the ocean, and there is no cohesion right now between them. And ideation is the first project that tries to do that, since it was founded by Mission Ocean, actually. So the word ocean was already also in the name of the call, but in particular it is very linked to the initiative that the European Commission is funding, that is the Digital Twin Ocean. So what the European Commission asked when they launched this call was to have this link, was to have a way to define a way to integrate inland waters into the digital twin ocean. So that's our goal as aviation. We are a coordination and support action. And so our aim is not to create this digital twin, but to develop this roadmap for the integration of inland waters into the digital twin ocean. We are 11 partners, all in Europe. We have also 2 associated partners, and Cetaqua is the coordinator. And the goal of ideation is to prepare the development of the digital twin of the inland waters. For inland waters, we are considering all type of waters that are rivers and estuaries, lakes, reservoirs, wetlands, groundwater, coastal water, snow and ice, and urban water. So the idea is to consider all these waters together or separately, depending on how we want to address this point. And the idea is to prepare the development of a future digital twin that will be interoperable with the digital twin ocean, in order to have this hydrosphere digital twin as a wall, a unique digital twin that will include any kind of waters. The overall concept to reach this roadmap, this ambition roadmap, start from having meetings and forums and to get requirements for different stakeholders. We consider multi-stakeholders in the sense that we are not considering only one discipline. We are not considering, for example, only expert on digital twin, but we are considering expert on digital twin, on any kind of inland waters, on digital tools in general, and we are putting this thought and their feedback all together together in the first period that just ended the requirements, and then to address with them all the results that we are going to have. Right now, we reached the 14 countries because we decide to apply a divide and conquer approach to not have all the Europe all together, because in our opinion, it could be better to divide the problems considering the specific site. As you see, also Malta is in this list, and of course the WATERLINE project is a supporter for us in this sense. In parallel, we are also creating an inventory that we called Open Keywords, that is a knowledge base where we are collecting policies, we are collecting results from European projects, we are collecting data sources, and we are putting everything together to see what is already there, to analyze which are the barriers, and also if well, of course they are, so to identify also the gaps. And the step that we are currently doing, and it must be finished in the next month of the project, is to have this kind of mapping to understand what the multi-stakeholder are asking for and what is already there, just to not reinvent the wheel, but to fill gaps and to overwhelm barriers. After this mapping activity, we will define a reference architecture. This reference architecture is it will compose of a set of building blocks put together in order to say which are the elements that are a must for the definition of the digital twin for inland waters. But of course, we have to take into account also the work that is currently under development for the digital twin ocean. And so we have also to take into account the building blocks that are there to check what is already covered by the digital twin ocean and what is very specific for the digital twin of inland waters, and so to having everything together. And at the end of the project, we will go to European Commission with this roadmap that will be like the cookbook to how to build a digital twin for inland water that is interoperable with the digital twin ocean. As I said, we divide Europe in different countries. Right now, we reached the 14 countries. We have a 15 almost ready to enter in our ecosystem. And we had several meetings with them. We reached more than 350 stakeholders in the first 10 months of the project. And the first questions that we addressed and we discussed with our stakeholders was to identify in each site the most relevant type of water for each of them. For example, in case of Malta, our stakeholders selected the urban water, groundwater, and reservoirs. So this was the first step. Starting for that, we started to define together, the requirements from them, especially focusing on each of their main interests. And in parallel, as I said, we are creating this inventory that is a set of 6 catalogs. And here I put the numbers to show what we have done in the first 10 months of the project in this direction. And we selected 39 policies. We selected 515 projects. That means 5,430 scientific results. And also considering the project, but also other open tools, we selected 1,071 tools and technologies. 5 open data sources have been identified, and 50 meteorological databases has also been considered in Europe, but also considering the associated country of the project, that are Switzerland and UK. And we are currently defining the reference architecture, and the baseline is the digital twin ocean, as I said, because we need to have this reference to check what they are currently implementing in order to be aligned with their work. In particular, under the umbrella of the Edito Infra project, they are giving an ecosystem where you may try models and services, and you have a set of data that have been published there, and so you may play with those data to start to have some kind of simulation, or also to define some kind of what-if scenarios. For us, this work is very important because is a way to play with what the digital twin ocean is offering right now, and also to give us hints and insights on how to build our digital twin for inland waters. And the final results of the project would be this roadmap. This roadmap will include several things, almost everything that will be done under the umbrella of the projects. So, for example, we will provide in this roadmap the list of functional and non-functional requirements that have been identified. They are already published in an internal deliverable, and for each of them we put also we point out also where, in which country they have been requested, because we think that is also important, since we had this work of dividing in different reference scenarios, also to take into account the different needs from different countries. And this roadmap will also include 8 reference use cases, one for each type of water. So we are, in this case, we are working locally to reach and define with selected stakeholders in 8 countries the corresponding reference use case, and that is like we go there and we ask, okay, in the case tomorrow you may have a digital twin for your type of water, which are the needs that you have, how do you think that it could be useful for you, and this kind of information. For example, I put here the example of the one that we are defining in Spain with Aguas de Barcelona, that is a water utility located here in Barcelona, that is also part of Veolia Spain. And we define together with them this hypothetical use case that is needed for us to better have an idea of what the final digital twin will be, and also to define everything, and in particular the reference architecture. And together to the definition of the reference use cases for each of them, we are also now in the activity of analyzing them from a SWOT analysis approach. So we are identifying for each of the reference use cases the strengths, the weakness, the opportunities, and the threats. And we are doing also, of course, in a co-creation manner together with the stakeholders. So in our case in Spain, together with Aguas de Barcelona, we define the reference use case, and together with them, we are now trying to identify this SWOT analysis to have this idea, and also to have a clear idea of what we are really going to have at the end of the project, because otherwise it will be very theoretical, and it will be difficult for the future to develop this kind of digital twin. And also we are in the roadmap, we will provide the reference architecture that we are defining. We can start from a very high level architecture and then going, like zooming in each of these blocks to see what they are composed of and which are the main components of each of these blocks. And together with all of these, we will have also a list of data sources that can be used. We will have also the interfaces to be considered to be interoperable with the Digital Twin Ocean and also with the Destination Earth initiative. We will provide technical recommendations, and also we will put an eye on the European and national meteorological services in order to take into account also everything that is related to climate change, to the Green Deal, and to a sustainable development. And that's basically what I wanted to show you, just to give an idea of what the overall ideation is currently doing. And of course, if there are questions, I'm really happy to answer them.
Eloisa, thank you very much, for your time. We really appreciate that you could share this with this forum. I think this forum brought about like-minded people in the water sector in Malta. Thank you also for choosing Malta as one of the places that you looked at a deeper point of view. Can I suggest that maybe you either type in the chat your email, possibly someone from the forum might want to directly contact you, either to give information or that is relevant even to help you build up this roadmap, which I think might.
We are all the time searching for new stakeholders, so everybody's interested in being contacted. Please send me an email, and we will be happy to involve you.
Thank you. So we're reaching the end, and as promised, so if you have any questions to any one of us, or would like to pass a comment, now is the time before we close off at past. Are there any comments, final points, burning questions that you might have that? I know it was an exhaustive 2.5 hours. So what if there are no questions? What I would recommend is we'll meet again on Thursday, and do let us know if you have any questions. Even I'll drop off our email just in case you'd like to contact us directly. It's the project's email. So should you have would like to or else contact us through our socials. And just even to conclude, first and foremost, I would like once again to thank you all for joining us this afternoon. I know that everyone is busy, and so finding these 2.5 hours today for us was a very important element that you gave us these 2 hours in enriching this forum. But basically, looking ahead of day 2, in day 2 we shall be shifting our focus more on the enabling environment. So in the second session, we'll be focusing on more onto research, not research outcome this time. It's more on the funding mechanisms that can make this innovation possible. We'll look into how policy frameworks and national strategies can be aligned with research and commercial efforts. We'll also discuss how to bridge the gap between policy making and also investing in these research outcomes. Okay, and also this will be we'll have a special will be supported in this session by our colleagues from Scienza Malta, who will be giving dedicated insights on even what funding this forum can look into and tap should they wish to either focus on research project, commercialization of digital technologies that they would like to invest. And to this extent, I strongly invite you to join us again on Thursday, 10th April, between same time, 2 till 4:30. The link is different, so you need to register again. Most of you have already registered for the second session. And as was done with this session, you will be receiving an email with the actual link. I would like to thank once again to all of our speakers and panelists and you participants for today's highly thoughtful insight and all your energy. Thank you very much.
Thank you.
Thank you, everyone.
Have a nice evening.
Thank you. Thank you.
Thank you.
Thank you. Bye.
Thank you.
Bye.
Bye bye.